So we had seen one example of how we can use queue to send data from one task to another task, and in this video we are going to look into some other examples as well, and some other functions how we can use the queue. So if you have seen the example here, I have sent three messages, message 1, message 2, and message 3, and I can see them on the printed on the terminal, which is done by my task 2. Now if I want to send data over to this queue buffer, I use the function xQsend, but I can also send it in the reversed order as well. So I can use a function called xQsend to front. So basically, if I'm, let's say I'm using xQsend to front, let me type it out first. Front, let me do that here as well. Okay, now what's going to happen is it will send message 1 to this queue, then it will send message 2 to the front of queue. So what's going to happen is when task 2 will read it, it is going to read message 2 before message 1, and the same thing happens for message 3. So it sends message 1, then at the front of it it sends message 2, and at its front there will be message 3. So if I run this program, you'll notice that the message order from message 1, 2, and 3, it will be in the reversed order. So let's go ahead and let's run that. Okay, okay, you can see it's printed message 3, 2, and 1. Let me reset it another time. There you can see 3, 2, and 1. So you can use the xQsend to front, and xQsend to back is available. That function is available, but it's the same as xQsend. So xQsend is basically xQsend to back. Now okay, now you know that the size of this queue is 5, so I've sent 3 different messages. So I want to see, I want to check here that how many messages I have sent in the queue, how many messages are there in the queue to be sent. So I'm going to do that. Printf messages in, okay, let me write it this way, number of messages in queue is multi. So I'm going to use a function called ux queue message waiting. So waiting to be read, and in the parameter I need to specify which queue. So since my queue is the x queue, I only have created one queue, so I am checking that. So let's go ahead and let's run this program and let's see. But just to point out that we are expecting the value to be 3, but we might not end up having 3 here. Let me go ahead and let me show you what happens here. Okay, what is the problem? Let's see, waiting, do I have any? Okay, yeah. Okay, so it's ux queue messages waiting. Okay, just messages waiting. Okay, forgot what that is. Let me clear this window here. Okay, see, the number of messages in queue is 3. Okay, now let me go ahead and let me put a small delay in between. So v task delay, and let's put a delay of 100 milliseconds. And the same thing I will put after message 2, 100 milliseconds. Okay, now let's go and let's see how the program behaves. Okay, you can see it prints message 1, then it prints message 2, and then it prints the number of messages in Q1 as well. Let me reset the CPU one more time. There you can see it prints message 1, message 2, then it goes back to printing the number of messages in Q1 is 1. Now what is happening is you have sent this data over to the queue, then you have sent the message 2 over to the queue, and then before it even sends the message 3 over to the queue, the scheduler will switch the context and it will move to task 2, and in task 2 it will start printing the 2 messages that has been sent. So it sends message 1, then it sends message 2, and then before it is about to send the message 3, it jumps to task 2, and there it starts receiving all the messages that are waiting in the queue, which is message 1, message 2. It prints those, and then there's nothing else to be read from the from the queue. So then it goes back to task 1 where it sends message 3 over to the queue this time. And since the queue was cleared after after the 2 messages were read, so when I'm checking how many messages are waiting in the queue, it just reads that there's 1 message waiting in the queue. So and this is what you just have to be this is a concept that you have to understand, that when I am filling out the queue, at the same time task 2 is going to read these these messages. So what I will do is I will suspend this task here so that it doesn't read anything. So vtask suspend, so it will suspend itself. And now let's see how this program will behave. Let me clear this. Okay, so the number of messages 3, so it doesn't even print any of the messages because the task is suspended. So it fills, the task 1 will fill message 1 in the queue, then message 2, then message 3, and then when it prints how many messages are waiting, it will say the number of messages in queue is 3. So you get the whole idea. So there is another function that you can use, printf the number of available space is, again mod d, and I can find the number of available spaces using a function called uxq spaces available, and of course I want to check the xq, so that's going to be the input parameter. So if I rerun this program, so there you can see the number of messages 3 and the number of available spaces is 2, and 3 plus 2 equals to 5. That is the size of the queue that we have determined initially when we created the task. Okay, and one more function that that you can use is xq peek. Now xq peek is same like xq receiving, but when you're reading the data, you are not actually pulling the data out of the queue. You're not creating an empty space in queue. You're just leaving the data in the queue as it is, but you're just reading it. So let's do that. Let me get rid of this null value, and let me use this function called xq peek instead of xq receive. So I'm just going to peek the function. I'm not going to receive it. I'm not going to read the value. So let's see what happens if you run it now. Okay, it keeps on printing. If you notice, it keeps on printing message 3. Now this is because the message 3 is at the front of the queue, so this is the first message that has to be read, and the message never gets pulled out of the queue. It just stays there, so we are just peeking into it. So we keep peeking the messages, and it just stays there and keeps on reading it forever. So this is one more function that you can use. If you want to reset the queue anytime, let's say, then I can use a function called xq reset, and the parameter is going to be, of course, the xq, the queue object that I have created. So this is going to reset my queue to its original state, and it's going to empty the queue. And there is another function called xq override. Now execute override is same as how you're going to write. The function is going to be execute override. You can override the data that you have already written onto the queue, but you have to be careful when you're using this execute, because this is only for queue of length 1. So execute override is used whenever you are having a queue of length 1 only. So it's not really important, but if you ever have your application that needs to override, it completely depends on your application how you want to use these functions. So these were some of the other functions that we can use in queue. And another thing, I just want to say that when you are sending a data or you are receiving it from an ISR, so you are sending a data from an ISR, you are sending a data to front from an ISR, or you are sending a data from to back from an ISR, or even if you're receiving from an ISR, there is a version of these functions that is dedicated for application in ISR. So you just need to use from ISR. So if you're sending it from an ISR, if this was this line of code was supposed to be inside an ISR, that's what you're going to use, execute send from ISR. If you are receiving it, if you're receiving a data inside a task and you know that data has been sent from an ISR, you use the same execute receive from ISR, and there's execute peek from ISR as well. So this was about a few of the queue functions that we can use in FreeRTOS.